Today we're going to talk about the activity series and the solubility rules. The reason why we need to know these is because not all double replacement and single replacement reactions work. It just depends on how reactive the elements are, or if when two ions come together, if it's actually going to form a solid. So let's look at the activity series first. Make sure that you know that the activity series is used for single replacement reactions. And like I said, it helps us determine if a reaction will occur. And in order for the reaction to occur, it says here that the element that is by itself needs to be more reactive than the element that's in the compound. So if you go to your reference packet, there is something called the activity series. It's right next to your list of polyatomic ions. So here is the activity series. There's an activity series of halogens, and there's an activity series of metals. We're going to be using the ones for metals a little bit more often, but the activity series works exactly the same. So what you need to know is that the higher up you are on the activity series, the more reactive you are. So, for instance, lithium is more reactive than strontium, and aluminum is more reactive than copper. So you're really doing it based on the placement on the activity series. So if the element that's by itself needs to be more reactive, that means that in a single replacement reaction, the metal that is by itself has to be higher up on this list in order for the reaction to occur. And we're comparing it to the metal that's part of the compound. If the element that's by itself is lower on this list than the metal in the compound, then a reaction will not occur. So let's see an example. Here we have magnesium plus nickel chloride. So the two metals that I'm looking for are magnesium and nickel. So magnesium is right here, and nickel is down here. Magnesium is higher, nickel is lower. Magnesium is by itself, which means that it's more reactive. Things that are reactive want to react with something else. So the more reactive the more reactive metal wants to be in the compound. So that means that magnesium is more reactive, it's going to kick out nickel. So then we just predict our products, nickel plus magnesium chloride. And then this is just like predicting our products that we have done. Now let's look at another example. Here we have chromium and aluminum. Chromium is here, aluminum is here. Chromium is now lower than aluminum is. That tells us that aluminum is more reactive and it's already in the compound. So this reaction will not occur. So if you wanted to write products, your products would actually be exactly the same because no reaction occurred. So then you put a double slash through the arrow and write no reaction. RXN stands for reaction. So that's for single replacement reactions. The next thing that we have to look at is our solubility rules. Our solubility rules are for determining if a double replacement reaction is going to occur. The first things that we have to understand is that soluble means that it will dissolve in water. So dissolves in water, the state of matter that we would put is aqueous. So that's our AQ. Insoluble means that it will not dissolve in water. And the symbol for that is an S. This is really important. A double replacement reaction only occurs if a solid or water is produced. Okay? Water is the only thing that we're dealing with that would have an L state of matter. Every other liquid-looking thing would be aqueous. All right, so let's go to our solubility rules so that we can learn how to read them. All right, let's zoom in here just a little bit. All right, that should be better. All right, so we have a soluble side and an insoluble side. What we want to do is always look at the anion in the compound. So the way that we read this is all nitrates, acetates, ammonium, and group 1 salts are soluble. So that one's pretty easy to read. Then we have all chlorides, bromides, and iodides are soluble unless paired with silver, lead, and mercury 1. Here it says all fluorides are soluble except when paired with group 2, lead 2, and iron 3. So all of these exceptions are talking about the cation that is paired with the specific anion. So here the specific anion that we're talking about are fluorides. This one says all sulfates are soluble except when paired with calcium, strontium, barium, mercury, lead 2, and silver. So all of these, any compounds that fall under these bullet points, we would put an AQ next to them, unless it's part of the exception. If it's part of the exception, we say that's part of the other list. The other list is solid, or insoluble. So for instance, it says all sulfates are soluble except when paired with calcium. So if we had a compound that was calcium sulfate, well, that's part of the exception, so it would be a solid. Insoluble. All carbonates and phosphates are insoluble unless it's paired with a group 1 and ammonium. Group 1 is group 1 on our periodic table. All hydroxides are insoluble unless it's paired with group 1, strontium, barium, and ammonium. And then the last one, all sulfides are insoluble except when paired with group 1, group 2, and ammonium. Sorry, there's one more. All oxides are insoluble unless they're paired with group 1. So this is how you read the solubility rules. Now let's actually look to see how this applies. So what we want to do is predict our products like we've been doing all along. So sodium and barium are going to switch places. So barium is now going to pair up with carbonate. Barium and carbonate both have 2 charges, barium a +2, carbonate a -2, so that's balanced. And then sodium and nitrate will come together. We want to go ahead and balance this reaction. So we have 2 sodiums, 1 sodium, so you put a 2 out in front, 1 carbonate, 1 carbonate, 1 barium, 1 barium, 2 nitrates, and 2 nitrates. So now we have a balanced reaction. Double replacement reactions will always start off with labeling both of our reactants aqueous. In order for a double replacement reaction to occur, our compounds have to be dissolved into water, which means that it's aqueous, so that the ions separate, because we said that ionic compounds separate in water. That's called dissociation, so that our ions separate so that they could repair up with the other ion. So both of your reactants will always be aqueous. Now we look at our products. Here we have a carbonate. So we go to our solubility rules and look for carbonates. Here we have all carbonates and phosphates are insoluble unless it's group 1 or ammonium. So carbonates are usually insoluble, and barium is not in group 1 or ammonium, so it's not an exception. So that means that it will be a solid. Then we look here. We have a nitrate. So here it says all nitrates, acetates, ammonium, and group 1 salts. There's no exceptions here. So anytime you see a nitrate, it will always be aqueous. So this reaction does occur because you produced a solid. This solid is called a precipitate. Any solid that is produced is called a precipitate. Let's try the next one. So we want to predict our products. So ammonium is now going to be paired up with hydroxide, and sodium is now going to be paired up with chlorine. This one happens to already be balanced. So then we know that our reactants will always be aqueous because they're dissolved in water so that they can react with one another. And now we have to figure out if any of these are a solid or aqueous. So I look at my anion, that's hydroxide. Here we have, looking for hydroxide, here. All hydroxides are insoluble except when paired with group 1, strontium, barium, and ammonium. So in this case, we have ammonium that's paired with hydroxide. So that means that it's an exception to the rule, so it jumps to the other side and it's aqueous. Now I want to look at NaCl. So that's chlorides. All chlorides, bromides, and iodides are soluble except when paired with silver, lead, and mercury. Well, our chlorine is paired with sodium, and that's not an exception, so it is aqueous. So since we have two aqueous products, that means that all of these reactants and products are totally dissolved in water, so all the ions are just floating around, and no ions have come together to form a solid. So that means no reaction occurred. So you put a double slash through the arrow and write no reaction.